Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 23, 2025, about 2 days ago. The big hook is a single masked diffusion model that unifies multimodal understanding and high-quality generation, delivering 1024 pixel text-to-image, precise grounding, and image editing with state-of-the-art results and faster inference. The paper is titled Lavida-O, Elastic Large Masked Diffusion Models for Unified Multimodal Understanding and Generation. And as we will see later, the gains are broad and practical. In brief, the model pairs an elastic mixture of transformers with a lightweight 2.4 billion generation branch and an 8 billion understanding branch, shares the first 16 of 32 layers, compresses visual tokens 4 times, and uses universal text conditioning, stratified sampling, plus planning with iterative self-reflection. Alright. Figure 1 shows a single masked diffusion model that handles understanding and generation within one system. The top row demonstrates text-to-image synthesis, which highlights high visual fidelity across diverse prompts. The middle left panel illustrates image editing, where instructions guide localized changes. The middle right panel presents grounding, meaning the model locates objects by name using bounding boxes. The bottom row depicts interleaved reasoning and planning, where the system plans, edits, or checks outputs and then revises them. So Table 1 compares capabilities across recent masked diffusion models and makes the takeaway concrete. Lavida-O is the only one that supports object grounding, 1024 pixel text-to-image, image editing, and interleaved generation, which means the system alternates reasoning and producing images to refine results. Mudit and MMADA top out at 512 pixels and do not offer instruction-based editing or interleaved workflows. The Lavida family handles image-level understanding only. Okay, Figure 2 shows how the unified masked diffusion pipeline connects understanding with generation in one pass. This figure visualizes how image semantics, compressed visual tokens, and the text prompt form the conditioning stream that guides prediction. On the left, the system extracts semantic image tokens and VQ tokens, which are discrete codes representing image patches. Through the center, the model concatenates these with the prompt and applies token compression that reduces visual tokens 4 times. On the right, the model predicts the clean sequence X0 and decompresses visual tokens to produce the edited or synthesized image. So, Figure 3 contrasts dense designs with elastic Mo-T, showing how the new design trims cost while preserving interaction. Mixture of transformers means separate expert branches for text and image that can share attention, like 2 teams consulting in joint meetings. The key changes are a smaller generation branch, which reduces parameters without hurting image quality. The second change limits joint attention to the first M layers, so only a subset of weights activates per task, which yields faster training and inference. Well, Table 3 reports text-to-image results and shows that Lavida-O leads unified masked models on overall quality. The base model reaches a GenEval score of 0.77. Adding planning raises GenEval to 0.85. Adding reflection lifts GenEval to 0.89, which signals stronger prompt following. On DPG bench, the system scores 82. The FID on 30,000 MJHQ prompts is 6.68, which is markedly lower than prior masked models. So while Table 3 highlighted generation quality, Table 4 shows grounding accuracy across RefCoco families. Precision at 0.5 means a predicted box counts as correct when its overlap with the target exceeds 1/2. Lavida-O leads across splits, hitting about 95 on RefCoco Test A. Scores remain around 93 on RefCoco Plus Test A, which is strong because Plus uses harder attributes. RefCoco G stays near 91 on the test set, reflecting consistent localization across longer phrases. Wrapping up, 2 takeaways stand out. A single masked diffusion model, powered by elastic mixture of transformers, unifies high-quality generation with precise grounding and editing, and planning with self-reflection measurably boosts fidelity and prompt following. The broader implication is a practical blueprint for scalable, efficient, multimodal systems ready for real workflows. Thanks for listening. I am Alex.